This is Telegram learning from Muhammad Amfra schools for grade 12 students. How are you, student? Please keep your physical distance. Stay at home. Please, student, protect yourself from COVID-19 or Corona. So this is a physics class. I am teacher Salaman Ali. We have already stopped on Unit 4. Unit 4 study electrical current and circuitry property. So we have started from electrical current, the definition of electrical current. So in much the same sense as the flowing of water molecules through the pipe, the charged particle can flow a wire and hence create what is called electrical current. It seems that electrical current is just like the flowing of water through the pipe. When you define that, electrical current is the flowing of electrical charge from one place to another place. So suppose a charge that indicates that Q is the amount of the charge flowing past a given point in the wire in the time. In such case, we say that the electrical current that indicated by I in the wires, I is equal to Q over T. I indicated that the electrical current, Q is the amount of the charge, T is the time it takes. The SI of current is ampere. It indicated by A, the name from the French physics and Romain. So we have 1 ampere, that means 1 coulomb per second. That is a current of say 3 ampere. For example, is a flow rate of 3 coulomb of the charge every second. In shortly, 3 coulomb per second. That is 3 ampere. When you see an example, the worked example, how many electrons pass a point in 5 seconds? If a current of 18 ampere flow in a conductor. Firstly, we can take out the given thing in the questions. The given thing is one is a times, that is 5 seconds, and another one is a current 8 ampere. So we have asked already how many electrons. So the first basic formula, I is equal to Q over times. When it comes to the solution, it derived from the I is equal to Q over times. Q is equal to I times T, we get. So Q is the amount of the charge, I is the current, T is the times. Is equal to 8 ampere, it comes from the 18 current per 5 seconds. Lastly, we have 14 coulomb charge. So already we have Q is equal to N times E. That implies that N is equal to Q over E. Q is the amount of that charge we have get from the question. So that is 40 coulomb per, we know already the amount of one electron, 1.6 times 10 to the power of negative 18. Lastly, we have 2.5 times 10 to the power of 20 electrons pass through the given conductors. The next lesson is drift velocity and current density. Firstly, we define that what is the drift velocity, and secondly, we can define that the current density. Let's see it. Drift velocity, in shortly Vd, is the average velocity that an electron reaches when electrical field is applied across a conductor. When you see the formula, the total charge is equal to the number of electrons times the charge per electrons. That means Q is equal to N times A times Vd times T times Q, small q. N is the number of electrons, A is cross-sectional area, Vd is drift velocity, T is the times, Q is the amount of the charge. So the drift velocity is then given by Vd is equal to Q over Na times T times Q, where I is equal to Q over T from the above. The driving of the drift velocity Vd is equal to I over A is cross-sectional, Q is the amount of the charge, N is the number of electrons, the number, I is the current. So the formula of the drift velocity, that is Vd, is equal to I over A times Q times N. The current density, that is J. J indicates the current density, the amount of the density of the current, is the current per cross-sectional area. J, in mathematical expression, J is equal to I over A. J is the current density, I is the current itself, A is the cross-sectional area. It is a vector quantity, that means it has a direction plus magnitude. Its unit is A ampere per meter cube, meter square. Sorry. The drift velocity in the term of the current density is given by Vd is equal to I over A times Q times N, where J is equal to I per A. So finally we come Vd is equal to J over Q times N. This is the relation between the drift velocity and the current density. This is the formula of the expression, the relation between drift velocity and the current density. So when you see an examples about the drift velocity, the worked example, the wire 4 millimeters in the diameter transfers a charge of 960 coulomb in 8 minutes. If there is 5.8 times 10 to the power of 28 free electron per cubic meter, find A, the current, B, the drift velocity. So there is everything in the questions. There is diameters, and there is amount of the charge, there is the number of electrons. When you come to the solution, A, I is equal to Q over T. Q is how much? 916 coulomb per 18 minutes times 60 is equal to, it becomes 0.2 ampere. 18 minutes is times by 60, because 1 minute is equal to 60 seconds. It can be changing from a minute to what? A second. So finally we have 0.2 amperes, the amount of the current which passing the wire. The second question is the drift velocity. Already we know, we defined the mathematical expression of the drift velocity from above. So Vd is equal to I times N times Q times A, the cross-sectional area, the amount of the charge, and N is the electrons, I is the current. So the current already we have find 0.2 ampere. So 0.2 over 5.8 times 10 to the power of 20. 8 times 1.6 is the amount of the charge, the 1 electron. 1.6 times 10 to the power of negative 19 times the cross-sectional area is pi times r squares. So pi times r squares, it's divided by 4 millimeters by 2. So 2.10 times 10 to the power of negative 3, the whole squares, the whole squares. When you multiplying these all things, then dividing by 0.2, 0.2 dividing by these all things, the result will be 1.17 the power of negative 6 meter per second. This is the amount of the direct velocity of an electron, or the amount of the charge. Students, this is the last lessons. We will see next times another points. Please, students, keep your physical or social distance and stay at home. Protect yourself from COVID.